is my home. I promise to keep it healthy and beautiful. I will love the land, the air, the water, and all living creatures. I will be a defender of my planet, united with friends.
My name is Commissioner Frank Avila, and the name of our show today is Wastewater, the New Oil. And I have with me as my guest Dr. Beverly Stinton. She's the Vice President of AECOM Water, a leading global environmental engineering firm. And Dr. Stinton is one of the world-leading person on wastewater, and she's the Director of Research. And we're very happy to have Dr. Stinton on our show.
Well, thank you.
Because we're all talking about the environment. Everyone's talking about the environment.
Yeah.
And everyone is talking about water is the new oil.
Oh, yes, I
See?
know.
And because before everyone used to fight over that oil.
Yeah.
and now we're going to fight over water. They say water's the new oil.
That's it.
But they're leaving out one part. They're talking about the portable water.
Yeah.
The top part.
Yeah.
You know, of what we drink. But no one is talking about the bottom part of us, what we eliminate through our waste.
Yeah.
And this is wastewater. So why do you think people are talking more about water is a new oil and not including wastewater?
Well, there's a lot of reasons. I think, number one, water, our drinking water, is probably one of the most important commodities ever that we've ever had. And so it's very important that we all do have good drinking water supplies. And we have a population of 6.5 billion people in the world, and at least 2.5 to 3 billion people don't have good water supply.
Yeah.
And so we know that, and we know that water is an essential part of our life. But the thing that I think we miss, and that many people don't think about, is that we really, when we have wastewater, we not only have the water that we need, but then we have all of these other commodities that are in our wastewater that provide energy. And we've now got the technology, and we understand how to be able to recover that good clean water and also all that energy. So if you get two things for the price of one, that makes it a very valuable commodity, and I think that's what wastewater is. It's a valuable commodity.
You know, for our audience, Dr. Stinton, I'll call you Bev.
Yeah,
is
that's
Beverly?
good.
Is Beverly, or
Bev.
is it called Bev?
Bev,
Okay,
yeah.
Bev. Bev, could you define to our audience wastewater?
Oh, wastewater is all of that water. It's actually three main components in wastewater. And often we can think about it on a color scale. We have yellow water, which is just urine. We have gray water, which is all that water that comes from our washing machines and our dishwashers and our baths. And then we have black water, which is really the feces that comes in to our wastewater treatment.
Poop.
Yeah, poop.
Poop, yes. Yeah.
And you and I work in the wastewater industry, which makes us an exciting pair to be around, right?
Yes.
But all of that has value. We see a lot of organic waste in our wastewaters. We see a lot of nitrogen and phosphorus, and all of these are very valuable commodities, a lot of carbon. And what is oil but carbon? And so wastewater is a dilute form of a good carbon source, and we can recover a lot of commodities from it.
So wastewater, probably, should we say water is a new oil, or should we say wastewater is a new oil, because it's a combination of water and the other ingredients that you just mentioned?
Yeah, no, I think in many ways we talk about water, and we know that all of these folk are investing in water, but really when they say that, I think they're investing in the whole water cycle.
Whole water cycle.
And that includes all the things that come into wastewater and all the things that we can recover from it. So I think it's just one big circle.
Yes, everything is in harmony with each other.
Maybe it's more fun to invest in. You can talk a lot more about investing in water than you can talk about investing in wastewater.
Right.
But
That's
yeah,
true. But you know, one of the first things we teach our kids when they're growing up is what? We teach them number one and number two.
Yeah, that's right.
Right?
That's right.
And then as we grow older and intelligent, we don't use those words. We don't use poop or urine. Or, but then as we get older, then we get back to using those words.
That's right.
But you know,
cycle of life,
yes,
right?
cycle of life. But you know, in today, every time I pick up a paper,
Yeah.
They talk about the environment. They
Yes.
talk about pollution, about greenhouse gas. They talk about pharmaceutical drugs. They talk about everything, being concerned about the environment.
Yeah.
And what do you feel are the big issues in today's?
Well, I think globally we see a lot of issues. Our organization works in 63 countries around the
63
world.
countries?
Yes.
And no wonder they have the expert
They have
working there.
lots of experts, I think. Yeah. But and you know, so we see a lot of the issues globally. But the really interesting thing is that many of the global issues are also happening right here in our own backyard. I think the big issues are these exponential growth of population. We have a huge explosion of population in the globe. Until about 100 years ago, we had about 3 billion people in the world. Today, we have 6.5 billion people, and in 50 years, we're going to have 9.5 billion people. We have a huge explosion in population occurring.
Yeah, there's a slide right there on the screen.
Yes, and you can see that it's taken us 2,000 years to get 3 billion people, I beg your pardon, in this world, and we're going to double that in a matter of 50 years. So we have this huge population explosion, and most of those population will live in urban areas, in very tight, small areas. They're not going to spread out over the countryside. And so what that means is that we have very big water and energy demands in those urban areas. And I think those are big issues, because not only whenever you have a lot of people living in small communities, tight communities, you have a lot of potential for pollution and disease. And so water and wastewater treatment is one of the greatest things that we have ever invented as people in this universe to protect our communities. Now, what we're seeing is that it takes more and more energy to provide that clean water to very small communities, and it takes more and more energy to treat the wastewater and prevent pollution when it's all localized and in tight communities.
Now, you mentioned that it'll take more energy. Now,
Yes.
now when you have this population in this small area, in the urban area, where are they getting their water from?
And that's a very important question, because now we're finding that a lot more of the water has to be pumped from very long distances. Now, we know here in Chicago you're really blessed with this tremendous water resource that you have.
The Great Lakes.
The Great Lakes. But I think the people in the southwest of the United States would love to build a pipeline to your water supply.
Yes, yes.
And that's you have a great water supply, but much of our country doesn't have water supply. And what we find is that here in the United States, a good amount of our energy is taken up in treating water and wastewater. But and that creates, when we use energy to treat it, it creates greenhouse gases. We're seeing big concerns about
And these are the climate changes that are
climate
occurring?
change,
Yes.
exactly. And so what we're seeing are all of these issues are interlinked. And if we could reduce the amount of energy we're using on water and wastewater treatment, but more importantly, reduce the amount of money that we're spending to pump water all over the place. Half of the money is spent in just pumping water to people and then pumping the wastewater away from those people.
And treating it, too.
And then there's only about a quarter of the amount is spent on treating water and a quarter spent on treating wastewater. Half of the money is just spent on pumping the water around.
And by energy, you mean energy is electricity?
Electricity.
And where do we get the electricity from?
Now, mostly fossil fuels
Fossil
today.
fuels, right?
Yeah.
So everything,
Yeah.
once you do one thing,
Yeah.
it affects another.
Everything else.
And Sherry, could you bring up slide 2? There's slide 2.
Yeah, a lot of people think about our wastewater as being a source of pollution.
Yes.
And I would like to point out the things that are actually in our wastewater. Certainly water, which can be recovered. We have a lot of carbon in there, mostly organic waste, we talk about that. But a lot of good nutrients, nitrogen and phosphorus. And today, though, we begin to see issues that we're able to detect a lot of pharmaceuticals and hormones in our wastewater. And unfortunately, we didn't know that much about these issues.
Pharmaceutical drugs and hormones?
Yes.
Now, are these a big problem now? Do we know? Or
We're not sure if they are a big problem for humans. And a lot of research is being invested in understanding that issue. And like most companies, we're taking a very keen interest and then working along with the United States Geological Survey to better understand this issue. But what we do know is that it's bad for our aquaculture. We already can see the impacts on fish and changing sex in the water,
Yes.
you know, downstream of
Yeah.
wastewater treatment plants. So we know that it has an impact on creatures that live in the water all the time, and that's their source of everything, their oxygen and so forth. As humans, we don't actually drink that much water every day.
We don't drink much water? I thought they said we have to drink 8 glasses of water, 8 ounces glasses of water a
Yeah,
day.
well, you would have to drink a whole Olympic-sized swimming pool to get one amount of a tablet
So
that
is
one
this
might
1
take.
per trillion or 1 per million? Or
Parts per trillion.
parts per trillion?
Yeah, so it's a very small amount
see.
that we actually ever ingest, and so there's very little evidence to suggest that it's going to affect you and I.
Sure.
But juveniles can be affected
Because they're smaller.
They're smaller,
Now-
and it builds up in breast milk for in mothers, nursing mothers as well.
Now, we talk about pharmaceutical in our water supply. How does that pharmaceutical and hormones get in the water supply?
Right. Again, it comes back to our cycle, doesn't it? In
Yes.
that what we use as our water supply has probably been contaminated to some degree by people who discharge wastewater upstream. Oftentimes, in inland areas, you draw our water from rivers, and along the length of those rivers, there are people drawing water out for drinking, and then the wastewater is treated and discarded back into the river. And so this is true, for instance, where I come from in the UK, in the Thames River, London. By the time it reaches London, we think it's probably been through 10 people.
So
yeah.
you're saying that a person, when they eliminate their waste,
It goes to a wastewater.
it goes down into a pipe,
Yeah.
into a sewer, it goes into a wastewater plant, gets
Yeah.
treated, doesn't treat the pharmaceutical drugs, and then it goes out into, then it's discharged
Into the river.
into the river, or
Yeah.
like we have our channels, discharging in our channels,
Right.
and that's where that's how the pharmaceutical drugs gets into the rivers and streams.
Into the rivers and streams. And you're very fortunate here because your water supply tends to be quite pristine from the Great Lakes or from groundwater supplies, and that's actually, as professionals in the water and wastewater industry, our first mantra is to protect human health.
Yes.
That's the first thing we always make sure that we do, and so we're always looking for good, clean water supply, always making sure that we protect our waters.
So
Yeah.
when we say wastewater is a new oil, then the pharmaceutical drugs, does that have any impact on the new oil, on water, staying in
No.
water, or not?
No, I think because we still have all of our carbons there. I mean, whenever we discharge our wastewaters, today in this country we treat that and we are able to recover all of that carbon.
Okay.
We get all the particles out, we get a lot of those nutrients back out. And that's something that I think we're all beginning to do a lot of upgrades. But in most of our wastewater treatment plants actually remove 60 to 80% of these pharmaceuticals. But they were never designed to do that. But we've done a lot of research through a lot of wastewater treatment facilities, and we find that bacteria are very effective at removing pharmaceuticals. And so, you know, it's if you want to find a bug that'll get rid of something,
Yeah.
go to a place where that commodity has existed. If you have a chemical spill, pick up the soil, because you'll find a bacteria in there that can disintegrate that chemical.
So the
Bacteria-
good bugs will eat the bad bugs.
Yeah, bacteria are very innovative. Yeah.
Now, do you think we are addressing these problems in the right way? You mentioned all of these concerns: population growth, demand for water,
Greenhouse gases.
greenhouse gases,
Yeah.
climate change. Are we addressing it the right way now?
Well, I think in our industry we do a lot of hard work to do a lot of good. But by virtue of doing good, we try to treat all of those contaminants that we know exist in our wastewater. And more we treat it to very extreme levels,
Okay,
so that it's almost non-detect. And you can see on the graph that we treat our wastewaters to these very low effluent levels so that they're very clean. But as you do that, we use a lot of energy, we use a lot
and
of
that's
chemicals.
that curve that's up.
And so
Yeah.
the more we treat it, the more we create demands for energy and greenhouse gases.
Greenhouse gases.
And so in an effort to do good, we often have this other environmental impact.
Now, explain to the audience how we increase the greenhouse gas by the energy that we're using?
Well, our wastewater treatment facilities, they're really, the way we treat wastewater hasn't changed in the last 100 years.
Yeah.
We know that bacteria, that is their food. They live on the wastewater. They actually consume the carbon. And so we give them oxygen, and they live in the wastewater, and they disintegrate or degrade the wastewater and remove all of the contaminants. And then we take the bacteria out, and we have clean water. So the bacteria are very effective in removing all of the pollution from the water, and we have good clean water, and then we have bacteria. But to do that, we add so much energy, so much oxygen, that it really causes a lot of demand. For about 50% of our energy at our wastewater treatment plants is just in putting air into the wastewater treatment. And so we could find a better way of doing that.
How about chemicals? Do we put any chemicals?
Put a lot of chemicals in. We make sure that we have the right pH in our wastewater. Yes. We make sure that we have enough carbon if we're trying to remove nitrogen. So we add a lot of chemicals. We put in ferric and alum to remove phosphorus. So we add a lot of money in chemicals. And all of those are chemicals that are created by industries that use a lot of energy. And so there are better and smarter ways to do a lot of these treatment processes, but historically, 100 years ago, we didn't know that.
Yes.
And so all of our systems are set up so that they take all of this wastewater to one central location, and we spend a lot of money and energy at that one place trying to treat these wastewaters. And so there are maybe better ways that we know of now to do how to do this and how to treat it better. But it takes a big change, and it'll take time to implement change.
But that's right, because time, because to make the change takes money.
Yeah, it takes money. Yeah.
And I attended your conference and your talk, your workshop, and you mentioned a holistic approach.
Yes.
And what do you mean by that approach? Could you explain that to our audience?
Well, we know that we're seeing a shortage of water supply. Even in this Chicago area, we expect that we'll see 40% population growth in the next 40 years. We know that industry is growing in this area. We expect to see a 60% increase in water demand just for industry. And the
now, is this you're talking about in our area
in
here?
this Chicago area, yes. Okay. And so what we know is we're also becoming a much more water-dependent people.
Yes.
Our population, our use of water outstrips our growth in population. It's growing at twice the rate. The amount of water we use is growing at twice the rate the population is growing at. And so there are concerns about where you're going to maintain the water supply. Now, what I think we can envisage is that the wastewater industry can actually solve the water supply problem, because if we begin to treat our wastewaters in a little bit more of a smarter way, we can reduce a lot of that water demand. Most of the water that we use every day is not for drinking or for cooking. A lot of it is for just bathing, a lot of it is for flushing toilets, a lot of it is for doing laundry. And there are many ways, and irrigation, about 70% of the world's water is just used to grow crops and to irrigate. And we can use a lot of our water just to close to those areas that we live in. We can reuse water, and it can be safe and effective if we do it the right way, and it will ultimately cut down on the water supply requirements. And so the wastewater end of the business could actually solve a lot of the problems in energy and also in maintaining good clean water supplies, but also dealing with the water demand for industries and for irrigation. And so there are new ways, a new paradigm.
A new paradigm?
Yeah.
Sherry, could you bring up that slide where it says a new paradigm? It's either slide 3 or 4. There, we'll bring that up, and it's the this is your new paradigm, right?
I think that we have a new and a sustainable approach ahead of us in the wastewater and water industry.
Explain that slide.
Well, sustainability. What is sustainability?
Everyone's talking about sustainability.
Yes, everybody's talking about
what does
it.
That
and what
mean?
does it mean? It means three main things. That we find an environmentally sound way to deal with the issues that is cost effective and enhances our communities. And it must meet all three of those things to really be a sustainable solution. So what we talked about before, where we add so much energy and so much chemical to get very good water quality, that's really not a sustainable solution. It's really it's the way that we've been doing things, but it's not sustainable. It's costly, and it needs a lot of energy and a lot of chemicals. And I think now that we're getting smarter about how to treat wastewater, I think we can really develop a new sustainable way of treating our wastewaters.
And in that triangle, the base, you got social, acceptable,
Yes, yeah.
and also you got economic
Feasibility. Yes, it has to be economically sound. It has to be environmentally efficient and effective.
And then,
but it
then
also,
you reach your goal
yeah,
up there.
and it also has to be acceptable and suitable for the community. Yeah.
Yes.
So that takes time to find such a solution. But a big part of the sustainability in treating wastewater is by beginning to think about all the commodities that are in wastewater and recovering them. So
no, because water is made up of what? H2O.
yes,
Right, and wastewater is made up of water, H2O, and all the other ingredients you mentioned.
exactly, carbon and nitrogen and phosphorus. These are all valuable things.
Yes.
And so we hear a lot about actually people investing in water today, and I think I mentioned that T. Boone Pickens and so forth
Yes.
are investing in water.
Yeah.
But if you can buy something that has water plus 3 other very valuable commodities, seems to me that that's where you would put your money, and that's
Yes.
wastewater.
Wastewater.
Yeah, and so we can recover a lot of energy, a lot of nutrients back from our wastewaters.
Energy, nutrient.
Yeah, and clean water.
And
good
clean
water.
water.
And the way that we can do that is actually by using things such as anaerobic treatment. We talked about how much energy is used
And
in
explain anaerobic treatment.
Anaerobic treatment in wastewater is where we don't add oxygen. All that money and energy that we said is added to treat wastewater because we need to give it lots of oxygen.
Yes.
We can treat it without the oxygen. There are bugs that will grow and
Sure.
that will recover the energy from the wastewater if we don't add the oxygen. And so we would cut down on all of that energy utilization. And lots of our facilities, and particularly here in Chicago, they're beginning to do this, that they're wastewater treatment plants, and have been for some time, treating the biosolids, the particles that come
Yes.
in the wastewater. They recover it and capture the energy out from all
And
of that
methane,
carbon.
methane.
And they produce methane gas, and that methane gas can be used for producing energy.
Yes.
And we can actually do that if we change the way in which we capture our wastewater. We could actually do that with all of our wastewater, not just the biosolids. And in the future, we'll talk a little bit a vision for the future as to how we could maybe do that later in the segment. But today it's possible at our wastewater treatment plants to begin to recover a lot of the energy from anaerobic digestion
Yes.
in the form of methane gas. And methane gas has 23 times the impact of carbon dioxide on greenhouse gas emissions. So if you can capture the methane gas, you've done as much good as you would have done if you captured 23 times
Sure,
that volume.
you're eliminating that CO2.
Yeah,
Yes.
yeah. And so that methane gives you energy,
Yes.
and it reduces the impact on greenhouse gas emissions. And so it is a double win. Often, we have this struggle between doing better things for the environment costs more money, and so it's always a struggle. But in this case, it's a win-win. It improves the benefits to the environment, and it saves us money. So there's really we now know how to do it well, and many of the plants in Chicago are really very far ahead of their time.
Well,
in how
we're
they're doing
at our
this.
Stickney plant. We capture
Yes.
methane gas, and we're using that as electricity
Yes.
at the Stickney plant.
Yeah.
But are there any other? Is Europe more advanced than the United States in this type of method?
And some of the things we're learning from our friends in Europe.
Yes.
They have we've been working a lot with the universities over there in how to recover energy and recover nutrients from our wastewater. And I give an example actually in one of the slides about technologies that we can recover from Europe. In fact, we have been testing one technology, and maybe it's the next slide. Yes, this is one technology from Europe that's on the screen now, and this is the normal, what we see on the screen right now is a normal 4-step process that exists for treating wastewater. And it goes through 4 steps, and you see it goes from ammonia to nitrite to nitrate, but then it goes back to nitrite and then to nitrogen gas.
Yes.
Well, we worked with our colleagues over in Europe and Delft Technical University to cut this 4-step process down to a 2-step process, which is what we see on the next slide.
Yes.
And what that means is that we are able to short-circuit the process, and we save on the amount of oxygen required.
And you mentioned oxygen required.
And we reduce the amount of carbon that's needed.
Yes.
And we can do it all in a very small, compact footprint. So we can learn a lot by working with our colleagues all over the world. And actually the wastewater industry is a very global and small industry. We talk a lot with our
Yes.
friends in
Everyone
Australia.
knows each other. Yes, we all know each other.
And you know, and so it's
Sure.
a very innovative community, and
Yes.
a lot of there's a lot of working together. But that's one form of a technology that we see mostly developed in Europe. But here in the United States, we also have a technology that was developed by NASA. And that's a technology that we're testing now, not just in the wastewater industry, but now not only in the space industry, but now in the wastewater industry. And I think that's this number 7 slide.
Slide number
Yeah.
7.
And it's actually a professor from MIT worked with NASA to develop this technology, supercritical water oxidation. And what it does is not just does it recover methane from biosolids, but it actually treats the biosolids to the point that there's no waste.
No, Sherry, could you? There's 7 right now, and that's no waste.
No
you
waste.
mean your human waste? Would you eliminate?
Yeah.
You're using your urine.
This actually, this takes anything that comes in, and it reduces it to the
wastewater,
form of just water, carbon dioxide, and some metal oxides and salts. And so you can recover very clean, pristine water, and then you can recover the carbon dioxide as an energy source, and then you can recover metal salts, and that's what's left. And you've nothing to dispose of except products that we need. The water, that's very valuable, the carbon dioxide, which is an energy source, and then we have our metal salts.
Yes.
And of course, in doing that, you produce energy. And so that's an exciting technology developed here.
Now, who's doing this now?
There's down in the city of Orlando, they're actually pilot testing.
Pilot testing it?
Yeah, but there's a full-scale facility in County Cork in Ireland.
County Cork in
actually
Ireland?
running it. Yeah.
I didn't realize that.
Yeah.
You know.
So it's actually oftentimes we develop great technologies here in
Yes.
the United
Yes.
States, and maybe it's just the right timing in other places, but these technologies are picked up all over the world and implemented. And so we're really entering a whole new era in the water and wastewater industry. There's so much innovation.
And no when we talk about biosolid, explain to the audience what biosolid is.
Biosolids are, after we've treated all that wastewater and we've grown all the bacteria effectively go into a digestion process,
Yes.
and they become a solid waste product.
Yes.
So the bacteria do all the work for us, and they gobble up all of the pollution, and they effectively become a waste solid product. And we treat that solid product so that it has no detrimental impact on the environment. It's actually very rich in carbon and nitrogen and phosphorus. And here in Chicago and in many cities, they beneficially reuse that biosolids product as a source of nitrogen and phosphorus
Yes.
for fertilizer.
Yeah, and we what our 5 million people give us every day,
Yeah.
as they eliminate their human waste and flush the toilet, we have about 550 tons of biosolids a day.
Yeah, that's a very valuable product.
Yes, and we give it away free
Yeah,
to the farmers, to golf course, landfills, for the covers.
yeah.
And now you're saying that
I think we can do even more. I think we can even recover more energy from that.
and you're saying that we could eliminate all that and convert all that to energy.
we could if
Maybe not 100%.
But it all depends again. A lot of money has been expended in developing the technologies that we have here in Chicago at the moment. So the process that's used here is a very sound one. We do recover energy, but we also give some of that biosolids away as a fertilizer.
Yeah.
That's a very good technology.
Yeah.
In other places, it makes where they don't have an opportunity, they don't have farmland nearby, it might make sense for them to go down this avenue of not having any waste product. And we see some areas of the country now, they're beginning to get nervous. They don't understand the great value of biosolids. Many communities don't want biosolids applied to their farmland. And I think they maybe don't fully understand the great value of that. But whatever the reasons are, maybe there just isn't enough farmland. In those communities, we now have technologies that can deal with the biosolids waste, and so that we don't have any solids to waste at all. And so there are always many decisions to be made.
Yes.
You know, it's never a simple answer to one question, right?
You know, I just did a show with Water for People.
Yes, yeah.
And they're working in developing countries.
Mm-hmm.
And they're trying to improve the water and sanitation.
Yeah.
So they're building toilets for compost.
Yes.
I'm wondering if in these type of countries how they could use this kind of technology.
I think it's often the Water for People organization is a fantastic organization that works at a very local level.
Yes.
And I think in those cases, what they do is the right thing. They're able to use that a very low-tech approach, and they're able to use the waste very beneficially for fertilizer.
Yes.
I think it's different horses for different courses. We're a city of many million people.
Yes. Here in Chicago, we got 5 million people.
And we don't have gardens and
No.
and fields right at our doors.
Right.
So we have to go another way to
Right.
the other end of the pendulum. And so in our situation, I think we have a different, we have the opportunity to use these technologies at very big centralized facilities, which is a very valuable thing.
And
it's a wonderful thing for our
economic
communities.
scale also.
Economy of scale,
Yeah.
absolutely. And we still do what they do at that very low level. We still produce a good fertilizer,
Yes.
and we produce energy.
Yes.
And so, you know, we're really not that different, except that we're much bigger, 550 dry tons per day
Yes,
versus, you know, possibly, you know, 3 or 4 pounds per day. So.
Do you foresee us as a wastewater agency throughout the United States going to this type of method of converting that biosolid into energy?
Yeah.
The way we're looking here in the United States on the cost of energy.
I think so. I think that's the great thing about. I think the future of the wastewater industry is going to change. I think as our communities grow, and we're going to see, as I said, maybe population growths in our communities and our cities by 40 to 50%. And those are going to be new areas. Maybe what we can think about is how we develop those new areas differently than we've done in the past. The problem is that in the past we've always had runoff and rainwater come into our sewer systems, and just as it shows here on the screen, there are probably new ways that these new communities can develop, that we could separate out the waste that we have, the valuable waste products, and treat them differently. And so you had a slide on the screen just a second ago, which
Sherry,
I think,
would you bring that up again, Sherry?
which I think is it tells us a new direction for the growth of our cities.
Yes.
In some of our areas, we can begin to do things differently. We can separate out our waste products. So we could maybe consider...
And waste product, again, the definition of waste product is what we flush down the toilet.
Yes.
We wash our dishes.
Yes. Bath water.
Bath water goes into our local sewers and come into our wastewater plants.
And maybe we can be smarter about it. Maybe we don't take our bath water and our laundry water and mix it in with our organic rich material, which is our garbage grinders, food waste, and the feces from the toilets. Yes. And maybe we keep urine separately. Those 3 things are very different ways to treat them.
Urine?
So urine is high in nitrogen and phosphorus.
Okay.
Our organic waste is high in carbon. But not nitrogen and phosphorus.
Okay.
So it can be treated for carbon.
Okay.
And then our grey waters is really very low contamination of anything.
Yeah.
And it can be very easily treated and reused locally. So maybe if we begin to separate out the 3 different waste streams and treat them according to their need,
Yeah.
rather than mix them all together. When we mix them all together, we have a very dilute wastewater, and it's harder to get the energy back out of that wastewater.
And that's an interesting idea. But we're here, let's give an example of here in Cook County, includes Chicago and 124
Yeah.
communities. How do we separate all three? How do we accomplish this? Because I think eventually we're going to have to do something.
I think it's a slow process.
Yeah.
In developed communities, I think it's going to be very expensive to implement this idea. But where it is going to be easy to implement is where our cities are growing and new developments.
New development?
Yeah. And I think, you know, our plumbing codes and so forth can lend themselves to working differently as our cities enlarge and we have new developments. And so I think it's harder in older, established cities where we have combined sewer systems.
Yes.
And combined sewer systems mean that it even takes the rainwater off
Everything,
the street.
yes.
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 In that case, it's very difficult to do it. But as our cities develop and grow, I think the new areas can actually look to changing how they collect these wastes, treating each of them separately.
Is this on the screen? Is it?
Yeah. So, for instance, if we see a new development, and that's in the blue area there,
Okay.
today, if we continue to do the same old thing, what happens is you have to enlarge the sewer that goes to the wastewater treatment plant, and then you have to enlarge the wastewater treatment plant,
Yes.
and then you have to find more fields to put the biosolids on.
And this is everything going into one central location.
One central location. Yeah.
And
But if we go the other way and actually separate out some of our uses, so we can maybe just collect in those regions as we build our new cities.
Richard, the next slide, slide 13, Sherry.
Yeah, if we can separate out the water and we treat the bath water and the laundry water
So
right there on site,
Yes.
we can use that water
Separate
again
on, you mean on site from at the house site.
at the house. Yeah, and
so
actually have a
we
separate
would need
pipe.
separate pipe.
Yeah, have a separate pipe to collect that very lowly, it's not very contaminated
Yes.
at all. It has soap and some other, and treat that locally with a very simple membrane technology, which is well developed now. We could use that water again as our toilet flushing water.
And that's a gray water.
And that's a grey water.
Okay.
And that's a reuse, or it could be used for irrigation in the summer and so forth.
Yes.
But then we just send the organic rich waste down in the sewer to this centralized facility
For treatment.
for treatment. And we don't want our rainwater going in there.
Yeah.
Let's keep our rainwater separate. It's usually not contaminated. We can treat large volumes of rainwater very effectively. And if we keep those things separated, then we're able to actually, at the wastewater treatment facility, begin to do things such as treat our waste anaerobically, and that saves us energy at the wastewater treatment plant as well. And so I think as we see our cities grow, we can begin to implement these more sustainable ways of treating wastewater, where we separate out the contaminants at source, and we're able to optimize the treatment specific to the contaminant. And we can actually recover a lot of our compounds like nitrogen and phosphorus more effectively.
You know, this idea is fascinating. Isn't it?
It is, and it's hard to
it's hard,
implement. I
implement.
think.
Yeah, that's what I'm going to say.
Yeah.
It's fascinating because we're all talking how to solve our environmental problems, which includes greenhouse gas,
Yes.
our water, our pollutants in our water.
Yeah.
And I'm just wondering how people here in the United States and our legislators
Very difficult, isn't it?
will take this idea
Yeah.
and implement it someplace.
And I think we
I mean, this is
and like so many,
this,
yeah.
And I'm going to send a copy of this tape to Washington D.C.
well, I guess you have friends there, right?
and because if they want to solve the problem,
Yeah.
we have to think of innovative ways now.
A new paradigm.
A
It's
new,
a
yeah,
whole,
a new paradigm.
whole new way of doing business.
And
yeah.
I don't know if they're doing this in Europe or not.
In some places.
Some places
yeah.
where-
Places that really, again, it started with places that had very little good water supply.
Yes.
So water was so valuable that they kept it very clean and they reused grey water again and again.
Again.
Yeah. And so
And
they
then
separate.
do they
have-
filter? Is there a
oh yes, it's highly treated. Highly treated.
and is it are they
Yeah.
using it for drinking purposes also?
And there's only one city that I know of that in Africa that uses wastewater as a potable water supply
yeah.
directly.
Directly?
And even here in the United States, in Orange County,
Yeah, they're doing a research. Is that a research, or are they
no,
actually doing
that's a full scale.
full scale?
And it's not direct potable reuse. That's where we have to be very cautious
Yes.
here. They treat the wastewater to the most pristine level, better than often our drinking water supplies are.
Yeah.
But then they put it into a deep groundwater
Okay.
aquifer, and it's there for many hundreds of years before it mixes in and it comes back as a source of water,
Okay.
drinking water
So
supply.
it's just starting right now for
Yeah.
for the future.
Yes, but I think in some places where water is so short, there is a city that actually uses direct potable reuse. So it goes straight from the wastewater treatment
Yes.
facility, and it's all one. It treats it to the very high level, and it goes back into the drinking water supply.
And this will solve our the water cycle. Right?
Yeah, I think that's a leap.
evaporates,
Yeah.
comes back, evaporates,
Yeah.
and it goes.
I don't even think we have to go that far.
To go that far?
I don't even think we have to go that far, because that's still so many things that we worry about, and hormones and
Yeah.
so forth. But all we need to do is stop using our really pristine water supplies for washing our cars.
Sure.
There's
sure.
no need to
There's
do
no
that.
need to use
And
that.
that would resolve, or to irrigate lawns, that would resolve 70% of our water supply.
70%?
70% of our
So
water supply
70% of our portable water is used for
non-potable uses.
non-potable uses.
And that's where we need to start.
Oh.
We don't even have to go that far, because there's a lot that we're still learning. So if we can just stop using all that really clean water supply for non-potable uses,
Yes.
then we can conserve and protect our clean water supplies for potable uses, for our drinking and for our cooking.
And this is why on your workshop that I attended, you were saying instead of saying water is the new oil, we should say wastewater is the new oil.
Because it resolves all of those
Resolves
problems.
all the
Yeah.
problems by implementing your 3 different ways of treating.
Yeah, the waste.
Yeah, the urine, the gray.
Yeah.
It's,
So it's a big challenge, though. It's a very our
Yes.
municipal agencies are so sophisticated
Yeah.
and have invested so much money
Yes.
in protecting water supplies that it's becoming harder and harder for them,
yes.
and much more expensive.
Sherry, could you bring up slide 8? I want Bev to go over nutrient recovery from wastewater, because to me it shows our resources are going
Yeah.
to be gone.
Yeah, that's true. If they
Yes.
say there's only another 100
And
years
it's
of
covered
phosphorus.
nutrient recovery from wastewater.
Right. Yeah, one of the things that we as our company has invested a lot of research
Yes.
actually in trying to recover nitrogen and phosphorus from wastewater. And we think that there's only about 100 years of phosphorus supply left. And it's a very valuable...
And what do we use phosphorus for?
Actually, for so many things, it's used in many of our detergents. It's used in for our own nutrients.
But now they say buy phosphorus-free detergent. Now we cannot. We have laws
That's
against.
a good thing. Yeah, phosphorus has actually multiple uses,
Yes.
and I think we're using it up and then we're throwing it into landfills.
Yes.
And we want to be able to recover the phosphorus, and we've been working along with these great technology developers to see if there are new technologies that we can even adopt from the mining industry.
Yes.
Start to talk to our friends in other businesses and other industries and see if we can recover these commodities rather than waste them.
And use them as a fuel source.
And actually, this is one thing that, it's an idea that my colleague came up with within our organization is, can we use ammonia as a fuel source? And we look back and we see that there are so many patents for use of ammonia as a fuel source. And we can recover that ammonia and blend it in with the methane at the wastewater treatment facilities and use it as a fuel source. And so today we spend all this energy trying to convert it to nitrogen gas. We could just save all that energy and use the ammonia, recover it, and use it as a fuel source. So there are many exciting technologies ahead of us that I think we can take to a new level in our wastewater treatment facilities. But it's a great business that we're in. It's a very exciting time for our industry.
And getting back to the 3 ways of treating our wastewater to help our potable water to solve our problems.
Yeah.
Are you getting more interest from, and you mentioned you're throughout the whole world,
Yes.
AECOM.
Yes.
Are you getting more interest and more calls to AECOM to see how they could implement this type of new idea?
Yeah.
Or is it a new idea? I mean, maybe it's been around for 20 years, 30
I
years.
think people have thought about it, and we've never really, it's never really taken off because we've always been a water-rich communities.
Yes.
And I think now that we see these huge growths in population, it's really causing some stress that we didn't have before. And in this country, we're hearing more about water reuse and how to use it effectively. We just completed a project actually where we tried to develop the right type of technology as an indirect potable reuse source, and we worked along with the University of Arizona, and we worked along with USGS to develop a bioassay so that we could make sure that all of those hormones were removed. And we use this bioassay, which is a biological response, to see that we've removed all of those different contaminants in our wastewater to make it a good drinking water source again. And actually that's one of the big areas of research. We talked about our hormones and pharmaceuticals.
Yes,
That's
because everyone,
Yeah.
the newspaper always have an article every 2 months
Yeah.
on our pharmaceutical drugs and hormones in our water supply.
Yeah.
And and everyone talks about it.
Yeah, and gets worried about
Yeah,
it.
everyone,
Excited
but no
about
one, they talk that it's present in our water supply or in our wastewater supply, but no one talks on how to cure it, how to solve that problem.
And we can do it, but it's costly.
It's costly?
Right? Yeah, it's very costly.
And by so instead of treating it at the back end, then
yes,
you're talking about treating it at the front end.
yeah, most of those hormones and pharmaceuticals are in the urine. They're not in the feces. They're not in the grey water. And again, the urine, if that were treated separately, we could resolve that issue much cheaper. The biggest part of our wastewater is dilution.
Dilution, yes. That's the way we used to treat.
So it's not, if we can do away with all that dilution and just treat a small, highly concentrated volume, we would be able to eliminate that problem. And there are many new technologies that we're looking at to even make it more cost effective.
Now, so if one has a new development, and the new development is going to have 10,000 people there. So is there a scale of population when one should have their own sewage treatment plant?
That's a good question. I think that's probably a community of a couple of thousand people is sufficient to make it feasible to have their own treatment system.
Okay, so now what I'm trying to get at is that in a home, in a washroom,
yes,
we have a urinal that we could urinate in, and that would go down a separate line, right?
Yes.
Into a collection system.
Yes.
That's probably out in the street.
And actually probably can serve a large population. A very small system could serve a very large population.
And depending the size of the pipe might not have to be that large because we're just dealing with urine.
And it could be a membrane treatment system with very advanced oxidation.
And that all that, say you have 100 homes, and you just urinate in a urinal. And it goes to a central location just to handle the urine.
Yes, and to remove all of those hormones and
hormones and pharmaceutical drugs.
and even to recover the nitrogen and the phosphorus.
And you cover the nitrogen and phosphorus that we could use.
That we could use again.
Again, yes.
And then if you have a vacuum toilet, for instance, which you use on aircraft.
Okay, a vacuum toilet, yes.
And that can deal with the black water
the
we
poop.
talk about, the wastewater, the waste,
Yeah.
the organic rich
Right,
waste.
I call it poop.
Yeah.
The kids.
And if we actually can mix the
Okay, and
kitchen waste with that.
Okay, and
that's very rich in
and that will
carbon.
go down another pipe in the house.
Yeah, and that can go to
into
a
another
centralized
a separate sewer.
Yeah.
And that will go to a central location for treatment.
Yes.
And then in that treatment, then we could either, as it treated, the end product could either be biosolid or we can convert that to energy.
That's right.
Right.
And energy
in the digester and the anaerobic.
Anaerobic.
And we talk about anaerobic is it's bugs that doesn't require oxygen, so
That's right.
we're saving on the oxygen.
That's right. Yeah, and that we can even take it all the way, as I said, with these new technologies, so that there's no waste. We could fully oxidize it with these new types of technologies.
And only you mentioned sand is left.
Yeah.
Okay,
sand,
so we got two pipes, separate pipes coming down from the house. Now we need a third pipe then.
And the third pipe can deal with just stormwater runoff.
Stormwater.
Bath water maybe, and laundry water.
And laundry water.
And that could be treated locally. Yeah. And that water could be reused.
By treating locally is in the house itself.
Actually, I think probably more still at a community scale.
A community scale.
And that can be again using these membrane technologies.
And by a community scale, do you mean a central location too?
So all of these could be at one location. Okay. But I think you can probably, for the water reuse, you probably want to keep that at a smaller community. Yes. And then the urine and the biosolids at a larger citywide community. So that the grey water, if we treated it locally, we can use that water for washing cars and irrigating lawns, and for using it even as flushing water sometimes for the vacuum toilets. And so we can use that water locally for a lot of good reasons, and we're not pumping water all around. And when we do that, we reduce the amount of pristine water that all of those houses are pulling in for drinking water supplies.
And this will save our water supply.
Yes.
It will solve majority maybe of our greenhouse gases.
It can help on that. Reduce our energy.
It'll save on polluting our streams and water and our water supply because of the elimination of your pharmaceutical drugs and hormones. So it will solve a lot of things that we're facing now.
And even the problems with infrastructure expansion.
Yes.
Yeah. As communities grow, cities are facing the problem that the pipes that they have are just not big enough. So we could eliminate that problem. Yeah.
I'm just wondering, has there been any study on costs?
Yeah, actually that's a good question. I think there are some studies on costs that show that it actually can be cost effective, if not even cheaper, in community levels, new developments to do this. I think it's very costly on existing
like here in the city
cities.
of Chicago. Yes.
Yeah, I think it's very costly.
And then when you mention it, let's say we were to go and mention it at a city council meeting.
Yeah.
And they would think, my God, is this guy nuts to do this? I mean, it'd be very costly, but something's going to have to be done to solve this problem.
I think, and we slowly can we have so much rejuvenation downtown and inner city rejuvenation that as we redevelop certain areas, we can implement these ideas and we can do things in a more sustainable manner in the future.
Yes.
But I think sometimes it's wise to evaluate the pros and cons. In our existing older city developments, it's probably very costly to do this. But in the new areas, I think we can do this and we can resolve a lot of the problems just there alone. But I think over time, as we rejuvenate much of our downtown areas, we can begin to implement these ideas.
And we could implement your grey water.
Yes, for reuse. And
reuse
Yeah, yeah.
on your new development.
Yeah.
Even though here in the Chicagoland area, we may not be able to solve all 3 separate lines,
Yeah, yeah.
but maybe we could solve one and have our biosolid
Yeah,
when we
still.
come to our anaerobic
Yes.
digester, that we could convert that to more energy.
Yes, which you're doing, I think.
Yeah,
and,
but not we're not doing all of our biosolids, but
okay.
maybe convert change a little depending on the cost.
Yeah.
Is converting a major portion of our biosolid towards energy.
Yeah, and all of these things.
And
though,
this will
yeah,
relieve the climate change, CO2.
It will. That we believe it's going to help. Yeah, that's
Yes.
true. And
Yes.
and I think everything that the water and wastewater industry is being challenged so much
Yes.
today, because not only are we trying to remove all the nitrogen and the phosphorus, and we're trying to reduce greenhouse gas emissions, and we're trying to deal with water supply. I think there are a lot of challenges and a lot of demands on our water and wastewater industry, and every situation is unique. And so I think the city of Chicago has always been a leader. Always been a leader. in the
Well,
water and wastewater
we're the
industry.
Metropolitan Water Reclamation District of Greater Chicago.
Yes.
We cover the whole county. We're not part of the city.
Yes.
We're not part of the county or the state. We're
Yeah.
our separate agency.
That's
And we just majority of what we do is we treat wastewater.
and well, that you've always had the reputation though of being innovators and leaders, and I think really have been ahead of the curve on these things. And I wouldn't be surprised to see the Metropolitan District actually begin to embrace some of these ideas in the new developments and new areas, because they have always been innovative, always have been leaders. Yeah.
And this is where research is very important.
Yes. Yeah.
And because we have to continue doing research.
Yes, and to make sure it's done right,
Right.
that it's managed
Right.
right. But there's so much of this is not just the technical side, and I think we talked about this before. So much of it is working with communities so that we educate communities and that they understand
And
why,
yes, why, yes.
and what to do to be sensible about water use. And I think there's a lot that we need to do. We don't talk about this subject a lot in public.
No,
you
and we should.
Yeah.
We should talk about wastewater is the new oil. They're talking about oil and water,
Yeah.
but they're leaving out wastewater.
Yeah.
And here we have the leading expert in the world, I would say.
Oh, I don't know.
Yes, Dr. Beverly Stinton, very well qualified. You're the director of research, and you're in charge of water on the water side, right, at AECOM?
And I mostly deal with the recoveries of the nitrogen and the phosphorus, actually, on the wastewater side, and new technologies. We're always excited about new technologies, and there are so many.
And
new
could you explain to the audience your background? I should have mentioned that at the beginning.
Actually, my PhD is actually in wave energy, believe it or not.
Wave energy?
Yeah, I did my PhD in the UK on wave energy, and so I've always been interested in energy.
Yes.
But my degree is in civil engineering and environmental engineering, and so it's the marriage of energy and wastewater treatment. There are very few businesses that offer all the exciting things that we do, and so we're on the verge of a very exciting era.
And your new idea, paradigm, changing the way we design our homes.
Yes,
and design our new
lives.
cities and lives.
Yes.
Excellent.
It's an exciting time.
Yes.
I will love